Welcome to the SRE screencast on zoned routing, Part 1, Concepts and Theory. Today's discussion will be broken down into three sections. In the first section, we will build ourselves a small imaginary network with which to discuss zoned routing. In the second section, we will go ahead and discuss the concepts and theory behind zoned routing using that test network. And then finally, in the third section, we will do a walkthrough of a call being routed under normal routing scenario and then under a zoned routing scenario. So whenever you're ready, go ahead and click next and we'll get started. The first thing we'll do is acquire some rack space in Los Angeles, Dallas, and New York. These will be our 3 POPs. Next up, we'll go ahead and order an internet connection in each of these 3 sites so that they can talk to each other. Following that, we'll go ahead and turn up some connections for a private transit network so we have some redundancy. And with that in place, let's go ahead and find ourselves some SIP vendors out on the internet at large. And then we'll go ahead and turn up some endpoints in Los Angeles and Dallas to reach those vendors. Then let's magically acquire ourselves a customer. And we'll turn that customer up in our New York City POP. And of course, we'll need to throw an SRE into the mix to route our traffic. And with that, we've got our test network built. So whenever you're ready, go ahead and click next, and we will jump into the general concepts of zoned routing. Okay, before we start talking about the zoned routing concepts, I'd like to briefly walk through what a call looks like on this test network today. So the call that we're going to walk through the network will come from our only customer in the New York POP, the SPR customer. That call will be routed by SRE. In our test call, ANI and TLX are the 2 vendors of choice. So the call would then route out to ANI, the first vendor, where it would cross the private transit network into the Los Angeles POP. From there, it would exit that POP over the internet connection destined for the vendor ANI. Okay, I think that's pretty standard stuff. Now, the whole point of zoned routing is to allow you to skip having to traverse your private transit network. In our previous example, we had to ingress an internet connection, traverse the private transit network, and then egress the internet connection on the far end. What zoned routing allows you to do is to effectively cut out traversing the private transit network. And we'll see how it does that shortly. The first part of zoned routing is the routing zone itself. Routing zones are abstract, but because the concept of zoned routing was created to avoid using the private transit network, it generally makes the most sense to create your routing zones based around the configuration of that transit network. So not surprisingly, for our test network, the 3 routing zones that we would configure would be Los Angeles, Dallas, and New York. There's one other crucial piece of information that is captured inside of the routing zones, and that is the zone egress cost. The zone egress cost is effectively the cost associated with routing a call over your transit network. And now that we've got our routing zones all set up, we can go into each of our existing endpoints and configure a home routing zone. The home routing zone should obviously reflect the routing zone that the endpoint already exists in. So New York for SPR, Dallas for TLX, and Los Angeles for ANI. So now we've got all of our routing zones and information configured, and we've got all of our endpoints in their appropriate routing zones. So far, zoned routing doesn't actually buy us anything, because when SPR asks for a route, if either of those vendors comes up, it has no choice but to route over the private transit network. So to start putting zoned routing to work, we simply get with our TLX vendor, inform them that we'd like to send them some traffic directly from our New York POP, and go ahead and turn up a new trunk group in New York. So under normal circumstances, if we wanted to route traffic to this alternate TLX group in New York, we would have to create an endpoint in SRE and assign a product to it. Of course, then that leaves you open to the possibility of sending a call to the TLX vendor twice in a row, once out of New York and once out of Dallas. So rather than turning up another endpoint in SRE, what zoned routing allows you to do is to configure a routing zone IP address for the existing Dallas endpoint. That endpoint currently has a home routing zone of Dallas, so we will be allowed to configure an alternate IP address in the New York routing zone for that same endpoint. With this information and with the routing zone configurations, SRE now has the ability to substitute in IP addresses depending upon where the call originated from. So in this case, a call originating from the SPR endpoint in the New York routing zone would always receive the alternate TLX IP address rather than the Dallas TLX IP address when it was requesting routes. The last thing I want to cover before we get into the call flows is the application of the zone egress cost. We talked about it earlier, and we know it's captured in the routing zone configuration, but we really didn't talk much about how it's actually used. The zone egress cost is added to the rate associated with any potential termination endpoint that's outside of the originating endpoint's home routing zone. Essentially what that means is if I want to route a call from the New York routing zone to an endpoint that I know is in the Dallas routing zone, I know that I'm going to have to traverse my private transit network. Therefore, I'm going to incur the cost associated with transiting that network, and that's the cost that should be captured in the zone egress cost. So as SRE goes through each of the routes, it will add the zone egress cost to any vendor who is outside of the originating endpoint's home routing zone. And it should be noted that SRE does consider an endpoint without a home routing zone assigned to it to be outside of its routing zone. One last thing to note is that there is the potential for a vendor with a higher rate to jump in front of one with a lower rate simply because of the zone egress cost not being applied to one and being applied to another. And we will see an example of this in part 2 in the configuration video. And that wraps up the discussion on the general concepts and theories. So whenever you're ready to jump into the call flows, go ahead and click next. Okay, first off, let's go ahead and remove that alternate TLX endpoint from the network for now. Okay, and with our network back to normal, let's go ahead and launch a call from our SPR customer in New York into the New York POP. The call would then be routed by SRE, and then let's say TLX is the first vendor. The call would have to route over the private transit network, and then from there would use the TLX endpoint and the internet connection in Dallas to get to the actual vendor. Then here in the zone routing example, we've turned up our TLX alternate IP again and launched the call from our SPR customer. The call comes into the New York POP, gets routing from SRE, and this time gets the TLX IP address of the New York endpoint, and the call turns around and routes directly back out the New York internet connection, thus avoiding the private transit network. And that will wrap it up for this screencast. If you have any questions or comments, my email address is on the screen. Thanks for watching.